Government agencies don't exactly have a reputation for moving fast, but right now, AI is changing that. And not in a slow, bureaucratic, let's form a committee kind of way.
We're talking defense, transportation, energy, and diplomacy. Agencies are deploying AI in ways that are genuinely reshaping how they operate. And if you work in GovCon space, or honestly just care about where public sector tech is headed, then this matters to you.
5 use cases, real agencies. Let's get into it. The first one is probably the most complex and honestly the most wild. Defense agencies are building what is called AI agent networks. Think of it less as a single AI tool and more like a whole team of AI systems working together. Each one doing a specific job, analyzing data, flagging threats, coordinating logistics, and all of them talking to each other in real time.
The reason this matters is speed. Military decision-making has always been a race against time. But when you're dealing with massive amounts of operational data across multiple domains like air, land, sea, cyber, humans simply can't process it fast enough. These agent networks are designed to compress that decision cycle dramatically.
And what makes this different from just using AI is the architecture. These aren't standalone tools. They are interconnected systems sitting on top of classified data infrastructure, high-performance computing, secure cloud environments, built to operate on real, authoritative mission data, not test data sets, live information.
The goal isn't to replace human judgment. It's to make sure that by the time a commander has to make a call, the picture in front of them is as complete and current as possible. Okay, second one, and this one hits close to home for anyone who's ever worked inside a large organization: data silos. You know the problem. Team A has the information that Team B desperately needs, but getting it across takes forever, or it just doesn't happen at all.
At the federal level, this problem is multiplied by sheer size and number of agencies involved. The State Department, for example, has been using AI to fundamentally rethink how their data ecosystem works. The idea is that diplomats in the field should be able to pull from multiple information sources in near real time, not wait days for a report to filter through.
What's making this possible is AI-powered integration, machine learning systems that can automatically clean, classify, and tag incoming data from totally different sources, and making it usable without someone having to manually standardize every single thing.
And look, the interoperability piece is huge. Agencies can only act on information they can actually access. If the data exists, but it's locked behind organizational walls or incompatible systems, it might well as not exist. AI is starting to knock those walls down. Third, this one surprised me a bit: transportation infrastructure. Department of Transportation is using AI to rethink how major projects get planned and evaluated.
And when you think about it, it makes total sense. Infrastructure planning involves an enormous amount of data: traffic patterns, freight movements, crash reports, satellite imagery, sensor data from roads and bridges. Traditionally, pulling all of that together takes months, which will require consultants, manual analysis, and endless back and forth.
AI is compressing that timeline significantly. Computer vision can process satellite and LiDAR data automatically. Language models can synthesize reports and flag safety risks that a human reviewer might miss buried in a page 400 of a dataset.
But here's the part that I think gets undersold. It's not just speed, it's the ability to simulate. Instead of committing resources to a design and hoping it works, you can now run the scenario virtually first. What happens to this interchange under these traffic conditions? What does this bridge design look like against projected freight demand in 15 years? You get answers before you break the ground.
That's a fundamentally different way of building, and it means fewer expensive mistakes at scale.
Number 4 is the one that honestly feels the most ambitious. The Department of Energy has something called the Genesis mission. and the name kind of tells you the scope they're going for.
Basically, they're trying to connect 17 national laboratories, roughly 40,000 scientists and engineers, and private sector partners into one unified research environment. Supercomputing, AI models, quantum technologies, advanced instruments, all accessible from a single platform.
The focus area are things like nuclear and fusion energy, grid modernization, quantum computing research, areas where the complexity of the problem is so massive that no single team or institution could crack it alone. AI becomes the connective tissue that lets all these pieces actually work together.
What's powerful here is the ability to run simulations and analyze experimental results simultaneously. Findings that used to take years to iterate can now feed back into models in real time. You're not waiting for a paper to publish. The loop is continuous.
It's a different model of scientific collaboration entirely. Less siloed, more networked. And AI is what makes the networking actually functional at that scale.
Last one, and it's the one that has implications way beyond defense, even though that's where a lot of the most advanced work is happening. AI-enhanced modeling and simulation.
The core idea: before you build something or train someone or commit to a strategy, you simulate it. Create a high-fidelity digital version of the system, the scenario or the environment, and run it through every condition you can think of.
The Air Force is doing this for crisis response training. Teams run through scenario-based simulations, real pressure, real decision trees, but in a controlled digital environment. You see how people collaborate, where decisions break down and what needs to be adjusted. And you do that before anything's on the line in the real world.
This also applies to the procurement side. Agencies can now test how a system performs under different conditions before they even write the request for proposal. That changed the entire acquisition conversation. You're not buying on faith anymore, you're buying with data.
As these models get more sophisticated, fed by more data, trained on more scenarios, the gap between simulation and reality keeps narrowing. That is where this gets genuinely powerful.
So step back and look at all five together. Agent networks, data sharing, infrastructure planning, scientific discovery, and simulation. What's the common thread?
Two things actually: interoperability, getting systems and data to talk to each other that never could before, and resource optimization, doing more faster with what you already have.
AI isn't a replacement for expertise or human judgment in any of these cases. It's what makes that expertise actually scalable.
If you're in the GovCon space, or you're just tracking where public sector transformation is headed, this is the direction. These aren't pilots anymore. This is where investment is going.
Drop a comment. Which of these five do you think has the most impact? We'd genuinely love to hear where you land on it.
And if this kind of breakdown is useful to you, follow CyberX Gov Solutions. We cover this space regularly. See you in the next one.